So this is a Wix 5, and in this session we will solve the previous year GATE question, particularly on the topic of air pollution. So beginning with the first question. So in 2018, the question came that, am I audible to all of you? Am I audible? Okay. So the first question says that there are 20,000 vehicles operating in a city with an average annual travel of 12,000 km per vehicle. The NOx emission rate is 2 gram per kilometer per vehicle. The total annual release of NOx will be. So they have given the four options. So when we solve this kind of question, so first of all we write the given data what they have given in the question. So first is total number of vehicles. So total number of vehicles. Total number of vehicles is 20,000. Okay, so and the average annual travel is 12,000 kilometer. So average annual travel is average annual travel is 12,000 kilometer per vehicle. Okay. Now the NOx emission rate is 2 gram per kilometer per vehicle. So NOx emission rate is 2 gram per kilometer per vehicle. Okay. So basically, so they are asking the total annual release of NOx will be. So for total annual release will be. So first is total number of vehicles multiplied by average annual travel, average annual travel multiplied by the NOx emission rate. Okay. So now to calculate the total annual release, is given by, so what the total number of vehicles are 20,000, and the average annual travel is 12,000, and the NOx emission rate is 2 gram per kilometer per vehicle. So here it is 2 gram, and in answer they are mentioned in terms of kg. So we have to convert this gram into kg. So 2 into 10 to the power 3 kg. So now the total value will come out to be 4,80,000 kg. So option A is the correct option. So whenever you get this kind of question, it is always better to first see the units and then you proceed. Since the question they are mentioned in gram, and however in the options they are mentioned in kg. So the answer is 4,80,000 kg. So anyone has any doubt in this question? Anyone has any doubt? Okay. So now moving to the second question. Now second question says a coal containing 2% sulfur is burned completely to ash in a brick kiln at a rate of 30 kg per minute. The sulfur content in the ash was found to be 6% of the initial amount of sulfur present in the coal fed to the brick kiln. The molecular weight of sulfur, hydrogen and oxygen are 32, 1 and 16 gram per mole respectively. The annual rate of sulfur dioxide emission from the kiln in tons per year up to 2 decimal places is. So for this kind of question, it is so basically, so they are asking, so 30 kg per minute the brick kiln. So annual rate they are asking. First of all, the question says annual rate of sulfur dioxide emission. The coal containing only 2% of sulfur is burned completely in a brick kiln at a rate of 30 kg per minute. 30 kg per minute it is burned. So the total coal burnt in a year in a brick kiln is, so 30 kg per minute. So for 30 kg we have to convert it into 30 kg in a year, for a year. So it will be 30 into 60 into 24 into 365. The number of, so it is given in per minute, we convert it into per day, and then we multiply it by the total number of days, that is 365. So answer come out to be 15768 kg. Okay, so we calculated the total coal burnt in a year in a brick kiln. Now the second thing which we have to focus is sulfur content. Sulfur content in the coal. If this much amount of coal is burnt in a year, what will be the sulfur content in this much amount of coal? So sulfur present in the coal, sulfur present in the coal will be 2%. So 0.02 into 15768,000 kg. So basically the sulfur content in the coal is 315360 kg. This is the sulfur present in the coal. Now, if you read the question, they are saying the sulfur content in the ash found to be 6% of the initial amount of sulfur present in the coal fed to the brick kiln. Now the sulfur content in the ash, this line. Now sulfur content in the ash we have to find. Sulfur content in the ash. Sulfur content in the ash is basically in the question they are telling 6% of the initial amount of sulfur present in the coal. So therefore 0.06 into 315360 kg. Okay, so we will get this as 18921.6 kg. So first we calculated, basically in this question we first calculated the total coal burnt in a year. Okay, once we know the total coal burnt in a year, we calculated the sulfur present in the coal. This is the second. Then we calculated the sulfur content in the ash. This is third. Now the thing is sulfur oxidized. So just sulfur oxidized into SO2 is oxidized. This is oxidized. Okay, so sulfur oxidized in the SO2, how much it will be? So basically, if 0.06% is content in the is present in the air, so obviously then 90 remaining, if 6% is present in the air, so remaining 94% will be oxidized into SO2. So 0.94 into 315360. This will come out to be 296438.4 kg. Okay, so now the first, so we calculated sulfur oxidized into SO2. It came out to be 296438.4 kg. Now from the chemical reaction, sulfur reacts with O2 and forms sulfur dioxide. Okay, so 32 gram of sulfur produces 64 gram of SO2. So basically we have to write this in line. 32 gram sulfur produces 64 gram SO2. based on the chemical react equation. So then this much amount of sulfur will produce how much of SO2? So 296438.4 kg sulfur will produce 64 by 32 unitary method simply into 296438.4. So if you calculate it, you will get 592876.8 kg. But in question, they are asking in terms of tons per year. Tons. We got in terms of kg. To convert it into tons, it will be 592.876 tons. Okay. So this was the solution, 592.876 tons. So initially in this question we calculate the total coal burnt in a year in the kiln, then we calculate the sulfur present in the coal, then sulfur contained in the ash and sulfur oxidized into SO2. So this much, then from the chemical equation we found 32 gram of sulfur produces 64 gram of sulfur dioxide. So using this we unitary method we applied, then how much amount of kg this sulfur will produce sulfur dioxide? It is 592.876 tons. So I hope with this will be clear. Is it clear? Okay. We will move to the next question. So in this question, so they are asking which one of the following is a secondary pollutant. So ozone, carbon monoxide, hydrocarbon, volatile organic carbon. So before solving this question, we should first know what is meant by secondary pollutant and what is meant by primary pollutant. So air pollutant is divided into secondary pollutant. Sorry, first it should be primary, then it is first divided into primary pollutant and then it is divided into secondary pollutant. Now pollutant, so basically primary and secondary. Now coming to the definition point of view, which is very important. Basically primary air pollutant are those primary air pollutant are those which are emitted directly from identifiable source. Okay, the primary pollutant are those which are emitted directly from the identifiable source. So examples of primary pollutant basically includes examples of primary pollutant. The first is finer particles. Second is less than 100 micron. Second is coarse particles. That is greater than 100 micron in diameter. Third is sulfur compound. Fourth is carbon monoxide. Fifth is halogen compounds. Sixth is organic compounds. Seventh is radioactive compound. Okay, and eighth is oxides of nitrogen. So you have to remember all these are primary pollutants since they are emitted directly from the identifiable sources. Now coming to the secondary pollutant. Secondary secondary pollutant are those which are produced in the air by the interaction among two or more primary pollutants, or by reaction with normal atmospheric constituents. The reason behind why I'm writing this definition because it is important, it will make your concepts clear. Atmospheric constituents with or without photoactivation. Okay. So basically, secondary pollutants are those which are produced in the air by the interaction among two or more primary pollutant or by reaction with atmospheric constituent with or without photoactivation. So their examples are first is ozone, second is formaldehyde, third is pan peroxyacetyl nitrate, fourth is formation of formation of acid mists due to reaction reaction of sulfur dioxide and dissolved oxygen when water droplets are present in the atmosphere. Okay, now this is fourth, and the fifth one is photochemical smog. Okay, knowing all these examples, now you can easily answer the question. So, which of the following is secondary pollutant? So, secondary pollutant is ozone. So, ozone is our answer because secondary pollutants are those which are produced in the air by the interaction among two or more primary pollutants or by reaction with normal atmospheric constituents. I hope this is clear. Anything? Anyone has anything to ask? Okay. We will proceed to the next question then. So the next question says the liquid form of particulate air pollutant are. So the liquid form of particulate air pollutant are basically mist and spray. So in this question, answer B is correct. So liquid form. So this is the question are the liquid from particulate air pollutants are. So it is mist and spray because, so just for your information, mist is a cloud made of very small drops of water in the air just above the ground, which reduces the visibility. Okay, so there are different forms are also like solid, liquid. So I will just give you a brief table so that apart from this, if any question they get asked, so you are able to answer. So basically, major classes, subclasses, and so the first class is particulate. So under this, there can be solid and it can be liquid. So for solid, it can be dust, smoke, fumes, and fly ash. Under liquid, it is mist and spray. Okay. Now second, under second organics. Under organics, it is gaseous hydrocarbon, then aldehyde and ketone, then it is other organics. Other. Okay. In case of gaseous hydrocarbon, it is hexane, benzene, methane. In case of aldehyde and ketone, it is for acetone and formaldehyde. Okay. In case of third, it is alcohol. Alcohol, chlorinated hydrocarbon. Chlorinated hydrocarbon. Now another third class is, it is inorganic. Inorganic is uh, oxides of carbon, sulfur, and nitrogen. Oxides of carbon, sulfur, and nitrogen. Under carbon, it is CO and CO2. Under sulfur, it is SO2 and SO3. Under nitrogen is NO2 and NO. So these are very important. So tomorrow, in next time, they can ask something from this only. What are the inorganic forms of carbon? So CO and CO2 or sulfur. So basically, you should remember all. It is better if you remember all this. So in this question, it was mist and spray. So I clearly elaborated the table. So it will be helpful for you. Now coming to the next question. So a bag house filter has to treat 12 meter cube per second of waste gas continuously. The bag house is to be divided into 5 sections of equal cloth area such that one section can be shut down for cleaning and or repairing. while the other four sections continue to operate. An air to cloth ratio of 6 meter cube per minute per meter square cloth. Is there any scope for of gate for pollutants on it? I think whatever I mentioned in this, it is better you remember that much, and you better solve previous year questions. So that can be helpful. Okay. And in question, also remember the mechanism behind the how smoke, what are the types of smoke, and what are the effects of pollution on humans, and what is photochemical smoke, what are their precursors. So it will be helpful if you read those. Okay, Binoy. Hmm. Okay, now coming to this, a bag of filter has to treat 12 meter cube per second of waste continuously. The bag house is to be divided into 5 sections of equal cloth area such that one section can be shut down for cleaning or repairing while other 4 sections continue to operate. An air to cloth ratio of 6 meter cube per minute meter square cloth will provide sufficient treatment to the gas. The individual bags are of 32 centimeter in diameter, 5 meter in length. The total number of bags required in the bag house is. So in this question, so they are telling the total number of bag required in the bag house. So a bag house, the first floor rate they have mentioned is they are treating 12 meter cube per second of waste gas continuously. So flow of air, it is 12 meter cube per second, and air to cloth ratio is they have mentioned is 6 meter cube per minute per meter square. 6 meter cube minute meter square. Okay. So now you can see if you so total to calculate the total surface area of cloth. So total surface area of cloth is equals to flow of air divided by air to cloth ratio. So see here unit you can see flow of air is meter cube per second. Air to cloth ratio is meter cube per minute per meter square. So if we divide flow of air to air by closure, we will get the total surface area of cloth. So 12 meter cube per second by 6 meter cube per minute meter square. Okay. So see, it is in second and it is in minute. So it is better we convert this also to minute. So if we have to convert this minute to second, we have to uh, multiply this by 60. So the 60 will come out in the numerator by 6. Now it will be in meter square. So it is 120 meter square. Okay. The total surface area of cloth. Now the area of each bag. So they have given the area of individual bag is 32 centimeter diameter and 5 meter in length. So area of each bag will be area of each bag. It will be pi dl 2 pi rl. So 3.14 into diameter they have mentioned as 32 centimeter for meter 0.32 and for length it is 5 meter. So 3.14 into 0.32 into 5 you will get 5.024 meter square. Okay, there. So this is the area of each bag. So therefore from this we can calculate number of working bags required. So total area we calculated 120. This is the total surface area of cloth 120. Area of each bag is 5 meters square, around 120 divided by 5.024. So we will get near to 23.88, which will be equal to 24 bags. Okay. So now this 24 bags, and in the question they have also mentioned that the bag house is divided into the bag houses to be divided into 5 sections of equal cloth area such that one section can be shut down for cleaning and repairing, okay, while a other section continue to operate. Okay, so in the next slide, since the bag house is divided into 5 equal sections of each cloth area, so that one section can be shut down for cleaning or repair. Okay, so therefore the minimum bags required per section is will be 24 by 4. These are the minimum number of bags. So 24 by, if we do, we will get 6 bags. So this is the minimum number of bags. Minimum number of bags required per section is, so this is the minimum number of bags required per section, because one will be kept for cleaning. So that's why 24 divided by 4 instead of 5. So this is a 6 bag. So now 6 bags. So total number of bags. So since they asked what, so in the question if you say that they have asked the total number of bags required in the bag of, so the total number of bags required is, so now since here totally we have 5 equal sections and we need 6 bag, minimum this much bag. So since they have asked since they have asked about the total bag, we will include this section also, 5 into 6, therefore it is 30 bags. Okay, so in this question the answer will be 30. So basically in this question what we did, the their question says the baghouse filter has to treat 12 meter cube per second of waste gas continuously. The baghouse is to be divided into 5 sections of equal flow area such that one section can be shut down for cleaning or repairing while the other portion continue to operate. And they have given the air to cloth ratio. The individual bag diameter and length they also have mentioned. The total number of bags required in the baghouse. So basically in this question the flow of the air is 12 meter cube per second and air to cloth ratio is 6 meter cube per minute per meter square. So from there we calculated the total surface area of the cloth. So we got 112 divided by 6, we got 120 meter square. So since this was in minute, we have to convert into seconds. So we multiplied the numerator by 60. So now the total surface area of the cloth came out to be 120 meter square. So now area of each bag, see the dimension of each bag is given, so we calculated the area of each bag. So it is 5.024 meter square. So number of working bags required. So this is the total surface area of the cloth and area of each bag. So number of working bags required, it came out to be 24 bag. Since 24 bag it came out, and the bag was divided into 5 equal sections, and one section can be shut down for cleaning and repairing. So basically minimum number of bags in each section, how much it will be? 24 divided by 4, because one section will be kept for cleaning. So that's why we are telling minimum number of bags, that is 6 bags. So the total number of bags required is, so we have 5 section and multiplied by 6, we get 30 bags. Okay. So there are few more things which I want to convey you. Like apart from this, there are few more topics. Like one is photochemical oxidation reaction. So one is photochemical air pollution. Okay. So this is also an important. They can ask you about the precursors required. So photochemical smog, basically photochemical smog is formed due to photochemical oxidation of hydrocarbon and nitrogen oxide. Okay. So under this, nitrogen oxide photochemical oxidation is also there. So photochemical smog is basically formed due to photochemical oxidation of hydrocarbon and nitrogen oxide. So in another side, we will look into nitrogen dioxide photochemical reaction. Photochemical reaction. Okay. So in this, ultraviolet length energy is absorbed by the NO2. NO2 absorbing HNO, it forms highly energized molecule this. So then it decomposes down. Then this, so after absorbing the light, it becomes highly energized molecule. Then it decomposes down to NO plus O. Then this atomic O oxygen, it reacts quickly with the molecular O2. So O plus O2 forms O3. This ozone may also react with the NO to form NO22 plus O2. So this is basically highly energized molecule. Okay. So after the absorption of NO2, after the absorption of ultraviolet light, it forms highly energized molecule. Then it's split down to nitric oxide and oxygen atom. So then this oxygen reacts quickly with this O2 molecular oxygen to form ozone. Then this ozone again reacts with the NO, and NO2 and O2 is forms. So another is sulfur dioxide photochemical reaction. Sulfur dioxide photochemical reaction. So in this, ozone O3 may be formed in the atmosphere as a byproduct during photochemical oxidation of sulfur dioxide to sulfuric acid. Okay, so this so there are various factors which affect the photochemical. So just factors affecting the photochemical reaction. Photochemical photochemical reaction. The first is light intensity. Second is hydrocarbon reactivity. Third is presence of light absorbers. And meteorological variables. Meteorological variables. And fifth is ratio of hydrocarbon to nitric oxide. So just remember on one more point, ozone and peroxyacetyl nitrate. Ozone O3 and peroxyacetyl nitrate are the most significant constituents of photochemical smoke. Okay, so these are one more thing. Also, it is very important for you to know, apart from this, the regarding the global warming, the major greenhouse gases are. So remember, one is carbon monoxide, second is methane, third is nitrous oxide, fourth is chlorofluorocarbon. Okay, so in a gate they can ask you which one of the following is a greenhouse gases. So you should know this. This is a very basic thing. And other is um, one more point which I want you to remember is atmosphere. Hmm. So also structure of atmosphere. Okay, structure of atmosphere is A is troposphere, B is stratosphere, C is mesosphere, D is thermosphere. Stratosphere ranges from 0 to 11 kilometer. It ranges ranges from 11 to 50 kilometer. Mesosphere ranges from 50 to 85 kilometer. Thermosphere ranges from 85 to 500 kilometer. Okay, so this is important. So this is for about today's session. If anyone has anything to ask, you can ask.
Sir,
Yes,
there was one question in GATE 2021 regarding
hmm.
ammonia nitrogen, uh, presence of ammonium and NH3 based on pH.
Yes. Okay. Actually,
It,
I have solved this question in. I think okay. In next class, then I will solve this question also. Ammonia and pH.
sir,
Okay.
okay, sir, I wanted to know whether it is found in it is in any book or it has
Uh,
out of.
Ammonia and question regarding pH, right?
Yes, sir.
So basically,
7 and 9.25.
okay. I don't have that book. Oh, okay. So you just read the ammonia section from any standard environmental book. You will get, I think.
Mm,
Like the
ha-
and there is a
have you
concept.
found out anything like that? Actually,
Uh,
I checked, but I didn't find anything like that.
okay.
So,
Yeah.
whether am I missing any source where I should be studying from? That's why I'm asking you.
Uh, See, like whatever standard books you are referring till now, refer that only because gate exams are near, right? In February.
Yes, sir.
So there is no need for you to refer any other standard books as of now. So better whatever
Yes, sir.
previous year questions is there, look for the solutions, what their solution says.
Mm-hmm.
Okay, and you read that only because this is the time when you should confined. You should not
Hmm.
make broad, right?
Yes, sir.
So in the next class I will discuss that also. Okay.
Yeah, sure.
Yeah. And other thing like try to solve previous year questions as much as time is possible, relate the understand the concepts behind it rather than learning the concept. Okay.
Yes, sir.
So and few more topics in environment, air pollution, you just focus regarding the inversion and all types of inversion air. So they can ask those questions also. And control devices for particulate matter, what is the diameter and all, right? There are so many are there, right? Spray tower, wet scrubber, electrostatic precipitator. So learn what are the diameters of which they remove and all. Okay. So you just, so should I write down the other important points which you should so types of pollutant removal, technology, types of technologies. uh, so air pollution technology, removal technologies. Because in 1 hour question it is difficult to cover inversion and their condition and what condition that type of inversion forms. So that are very important. And what is lapse rate, what is adiabatic lapse rate. So it is better to you just read. And there is a plume behavior. Okay, you just read all those for better understanding and conceptual clarity. And in next class I will solve the question which you are asking. Okay. Okay. Yeah, welcome.